So there will be different ways to kind of solve this problem to make the P ratio actually all filled in instead of having blank values. I will introduce one way. I think it's probably the most easy to understand. Okay, there will be other ways which we'll have to introduce some other DAX functions. Okay, so which may make things more complicated. So let's concentrate on this kind of simple fix. So the problem basically stems from the last trading day of a month may not be the same as the last calendar day of the month. Okay, so the historical daily table always have those trading days. Okay, so when the last trading day is not the same as the last calendar day, we cannot basically retrieve information from the quarterly income data set, because in that table, the date is always the last calendar day of a month. Okay, so if we can change the last trading day of a month to be the last calendar day of that month, okay, then this historical daily table can be easily linked with the quarterly income table, okay, based on the last calendar day. So that's the approach we're going to take. All right. So to do that, we're going to again, under the historical daily table, we're going to introduce a new column. And I'll just paste my DAX code here. This column is called DateAdjEoM. Okay, that stands for date adjusted for end of month. Okay, so basically I'm going to do the following exercise. I'm going to check the last trading day of a month. If that date is not the same as the last calendar day of the month, I'm going to change it to the last calendar day of that month. Okay, so in this column, there's several steps. Okay, I'm going to use the intermediate variables to do that exercise step by step. So the first step, I'm going to use the window function. And in this function, first of all, we have been talking about the index function, window function. They are actually quite similar in terms of structure. Okay, so in the window function, we have this match by, which confirms that this historical daily table is identified by stock symbol and date. Okay, so each row is a unique stock symbol combined with a unique date. And we are going to partition this historical daily table based on stock symbol and year month. So each combination of stock symbol and month is going to be a particular group. Okay, so for example, Apple in July 2023 is going to be a group. The next group is going to be Apple in August. All right, and the third group is going to be Apple in September, for example. So each combination of stock symbol and year month is going to be a particular group. Then within this group, we're going to order the rows according to the date. All right, and by the default setting, it's going to be ordered in ascending order. Okay, so pretty much we're going to resort this historical daily table first into several groups, each group being a stock in a particular month. Then within that group, we're going to order the rows according to the dates, all right, in ascending order. So each group is Apple in a particular month, and each row is going to be that the particular date ordered ascendingly. So we're going to go from the first day of the month, first trading day of the month, all the way to the last trading day of the month, okay, for that particular group. So that's basically how those arguments kind of sort the table of this historical daily table. Okay, then once that sort is done, we're going to retrieve this block from that historical daily table. Okay, what this block means. All right, so based on the current partition, so if the current row context says that we're focusing on Apple on say July 3rd, 2023. Okay, that's the current row context. So that basically tells Power BI we're focusing on Apple in July. All right, so that's the current partition we're going to focus on, right? Because partition here is defined by stock symbol and year month. So based on the current row context, which relates to Apple on July 3rd, 2023, the partition here should be Apple in the month of July of 2023. Okay, so the current partition is Apple July 2023. Then the window function is gonna retrieve from the first observation all the way to the last observation of this current partition. Okay, so ABS stands for absolute. We're not talking about relative positions. We're talking about absolute positions. Okay, the very first observation and the very last observation in this current partition. All right, so basically, again, recap. Assuming the current row context is related to Apple on July 3rd, 2023, then this will determine the current partition is going to be Apple in July 2023. Okay, so then the window function is going to retrieve the first row and retrieve the entire block, starting from the first row all the way to the last row related to Apple in July 2023. Okay, so this is what the first step is going to do. So once this block is retrieved, it's basically the entire month, okay, for the current partition. All right. Then the second step, we're going to use the max function to scan this entire block. Okay. Again, the entire block is Apple in July 2023. So this second step is going to scan each row for Apple in July 2023, and it's going to retrieve the maximum value of those rows in terms of the date. Okay, so because we're just scanning each date of July 2023 for Apple, and we're going to take the maximum date, okay, out of those rows. So basically what we're doing is we are going to retrieve the last date in July 2023 for Apple. Okay, so that's what the second step is doing. We're taking the last date in this current month for this current stock. Okay. Well, the third step is going to use this last date of the current month. Okay, it's going to check if this last date of the current month is the same as our current date. All right, so because again we're scanning this historical daily table row by row. The current row of this table will have a specific date. Okay, so if that date is the same as the last day of the current month, well, we'll need to make some changes. Okay, because now we're basically looking, well, if this condition holds, if the current date in the historical daily table is the same as the last day in this month, well, last trading day in this month, then we need to check if this last trading day of the month is the same as the last calendar day of the month or not, right? So basically, regardless, as long as we are focusing on the last trading day of the month, okay? So as long as this condition holds, then basically means the current row context is related to the last trading day of the month. Okay, in this case, we're going to change this date to be the last calendar day of the month. How do we do that? We use this function called E of month, basically end of month. Okay, so if the current row or the current date is the last trading day of the month, we're going to change this date using this E of month function. We're going to change this date to be the last calendar day of the month. Okay. Otherwise, okay, if this current date is not the last trading day of the month, if this condition does not hold, then we'll just keep the date as it is. Okay. In that case, we'll just return the date itself without changing it. Okay. So basically, the third step here, we are using an if function. Okay, we talked about if function before. Again, let me recap. If function will first check whether this condition holds or not. And basically, this condition says we are checking whether the current date is equal to the last trading day of the month. Because M, well, again, M is the value from the second step. M is basically the last trading day of the month. Okay, so we check whether the current date is the last trading day of the month. If this condition holds, then we're going to change this date to be the last calendar day of the month. Okay. If this condition does not hold, so if the current date is not the last trading day of the month, we'll just keep it as it is. Okay, without changing this date.